Today I'd like to talk to you about distillation. We're going to talk about two types of distillation in this lecture. One is simple distillation and the other is fractional distillation. So the idea here with distillations is that you use it to separate liquids or liquids from a solid by boiling points. The idea is that the more volatile component is vaporized and condensed, leaving the less volatile component behind. You can kind of imagine this. This is a setup for a larger scale distillation. Imagine that in this you had a mixture of, say, ethanol and water. Ethanol has a boiling point of 78.5, I think, degrees Celsius, and water, of course, is 100. Now, there's some stuff going on here as far as vapor pressure and Raoult's law, for example, but to imagine that you take this and you put this in a water bath. You got water right there, and then you got your hot plate down here. Okay. As you start to add heat to this, the ethanol is going to come off first. So it comes off as a vapor, it travels up here. This is a thermometer. As it travels up, it has nowhere to go except to curve around down this direction. And we have this special type of glassware called a jacketed condenser. And a jacketed condenser has, it's like a long tube essentially here with these little arms on it. And inside the tube there's like a pathway here. Right, so what happens is water comes in here, but it doesn't come into this area, and it circulates through. And it comes on the other side of this thing too. It cools down the inner walls of the tube here where the vapor of ethanol is, so it helps it condense, and it comes down here, and we collect ethanol down there. It's not perfect because you turns out that you can't get 100% ethanol. There's other problems that are there, but you definitely are more enriched in the lower boiling point compound as you proceed with your distillation. Now, for us, we use microscale. So the microscale setup for this looks like this. Got a hot plate here. This is aluminum. So we have aluminum shot down here. You got a spin vane in there. It's connected to something called your Hickman head. We use a digital thermometer, and we have a mini hood to collect any of the fumes that might be coming out. We want to try to avoid the fumes coming out too. Same idea, as you start to boil, the vapors come up and they come through here, right? And then if we don't go too fast, we allow it time to kind of condense around the outside of that, and then it comes back down here, and there's like a little well. You guys can see there's like a dip there. So to get this out, you would just take your cap off and you would stick in, right, your pipette or something like that. It goes into the well there, and you pull it out. So pretty straightforward thing to do. Now let's talk a little bit about the theory here. So let's take a look at the next page here, and we're going to look at something called the binary liquid vapor temperature composition diagram. It's got a big name. And this thing is constructed by taking a y-axis, an x-axis, and then one more y-axis. It's going to look a little bit kind of like our melting point composition curves that we did way back at the beginning of the semester. So over here, let's put temperature, degrees Celsius, temperature, degrees Celsius, and then down here, present composition. So you got your percent composition down here. And then let's just pick a point right there. Okay, and then let's call this 100% A. So what this would represent here then is the boiling point of pure compound A. Right? It's just an arbitrary place that we picked here. So we'll have a mixture of A and B. So if you're 100% A here, then probably 0% B on this side. And then moving over to the other side, let's pick a point. Let's just make it higher up here. And let's make this 100% B, and then therefore that's 0% A. Right, now that would be then the BP of pure compound B. All right, so in an ideal situation, what happens is you have your higher boiling point compound. As you add more and more and more of your lower boiling point compound, eventually the temperature comes down to reach the boiling point of pure A. Now it turns out that it's not a straight line that connects these 2 points. Instead we get like a little sliver. So do your best to try to draw in a little sliver like that. Now here's how we use these diagrams. These things can be they can be constructed through experiment. You don't normally find data like this in tables because there's too many liquid combinations that you might add. But let's just say, for example, that we start off with a composition of, say, 90%, I guess that'd be 90% B over here, 10% A. All right, so this is what's inside of our flask, right? Round bottom flask or whatever we have. So we have our setup and all that stuff, right? Like our microscale thing set up, and we start to boil, or I should say we start to heat, right? So eventually what happens is you add energy in, right? This is heating, getting hotter, getting hotter. If we look at our y-axis, temperature's going up, right? And we come up and we come up and we come up, and then we hit this point right here. So below that point, down here, we're a liquid, right? At this point, we start to see bubbling occurring. And we come over here, and that temperature would be the boiling point at 90% B slash 10% A. Okay, so we could measure that. Now, when something boils, it's in equilibrium, so we shouldn't see an increase in temperature here. Instead, what happens is we get like a little plateau, so a straight line that comes over like this. And that line is an equilibrium between a liquid and a gas. So a gas is coming off down here, right? We've got liquid gas, we've got vapor being condensed. So we're condensing right now to this point here. And then that's vapor, that's the vapor. And then this is what we would collect in our Hickman head, or that receiving flask in the larger scale distillation. So that's what we collect. So down here, this is important to point out. Here's what we collect. And you know, we look at our scale here. I don't know, if that's our 50 point, we might call this, what, 70% B, 30% A, right? Something like that. We're just making a guess there. So that's the idea. Again, to go through that one more time, you're heating it up, you're heating it up. This is a liquid, this is in your flask. It starts to boil. Right? As it starts to boil, you come over here and you collect this vapor, and that condenses back down to this percentage. And notice that we're more enriched here. We went from 10% to 30% in the lower boiling point compound. So here's a question I have for you guys. If we wanted to purify this further, then couldn't we collect this vapor, because this is a liquid right now, and we could re-distill this, right? So we'd come up, if we did another distillation, we'd come up here, come over, and that's what we would collect down here.